Hi, I'm David Anderson. This is the first Monday meeting of the Timex Sinclair online user group. It's Monday, November 7th. It's 9 p.m. Eastern time. And our little group of fan club folks, users and programmers have been very active over the past few weeks. Jeff Burrell's been doing some Python, I almost said Pascal. And it sounds like Tom has made some progress on his Lisp project, which is a thing that I never, would have thought that I would say in conjunction with Timex. And we have Stewart and Tim joining us tonight. I expect they'll probably want to tell us about their project. But since we have Adam and Ryan and Carl all at the same time, the three key members of the Albuquerque Timex Sinclair user group fan club extraordinaire, I thought that they could start off by telling us about their recent in-person meeting.
Sure. Well, we had it, let's see, when did we have it? It was on the 22nd. So it was like Saturday, the 22nd. And we met, Carl came over here at like 1 in the afternoon to my house. So in this very room, this very spot. We got together. He brought along his little miniature dig dug machine. And Ryan came over about half an hour later, I guess. And it was a good time all around. We went out to have a lunch together at a pizza place because that's what people do who use computers. And we hung out until I had to go out that evening. My friend's birthday was coming up and she was having a get together. So we nerded out and geeked out and played some video games and had talks that only geeks can have about geeky subjects, especially about 8-bit machines. So, yeah.
Is that accurate, Carl? Or is he just telling tales?
No, that's about accurate. Yeah, I know we had, it wasn't all Timex. I know Ryan brought over his Pi 400, right, which he does all his emulation stuff on. So he didn't bring over like a Timex machine. I know we took yours apart, Adam, right, and kind of showed you the adjusting the capacitor trimmer for the main clock to help the fringing.
Yeah.
I call it fringing on the color, the various colors on your CRT screens. You can, slow that down or speed it up so that it makes it easier to look at, right? I think
it was kind of interesting to see. I don't know if you were able to slow it all the way down, but when you slowed it down very, very, very slowly, the screen looked like it was going.
Yeah.
Really?
Yeah, it was pretty cool.
Yeah, that's kind of a trick I learned when I was, testing all those Timex machines for art. I would adjust that. I had certain color combinations I think I put up on there, and that made the fringing the worst, right? And you would adjust it to make it make that oscillation very fast, so it almost kind of like disappeared and it looked very nice. And yeah, the dig dug machine I think I brought over because I know.
Yep.
Oh no, it's a Qbert. Well, I brought
Qbert,
the dig dug, but I brought Qbert as well because
right.
we were doing all the you're doing all the Qbert disassembly.
What was
right?
neat about the Qbert? It's about, what is it, about 1.5 feet tall? Maybe not that.
Yeah, it's a 6 scale of it.
Okay.
Yep.
And I was holding it in my lap, and he's like, "Well, let's wait. Do you know what it's going to do?" And I'm playing the game, and all of a sudden, Qbert falls off the screen, and all of a sudden, there's a knocker inside the little cabinet.
I was going to ask.
Screen my legs, and I'm like, "Whoa, what the hell?" Yeah, that was a little surprise,
Yeah, that's the only arcade machine because I used to work in an arcade back, in high school here in Albuquerque called the Game Room, and I did conversions and obviously maintained all the machines and the pinball machines, and that was the only arcade machine I can ever recall that had a knocker like that in it, right? I mean, the pinball machines obviously had, all of them had them, but because that's how it would always, hey, you got an extra credit or you got a high score or something like that, it would hit that knock, that solenoid against the wood cabinet. But yeah, it was a good time.
Yeah, we'll get it together again and do it again soon. And everyone here is invited. You have to private message me for my address, all right?
If you're in the time of year when that sounds pretty inviting.
That's awesome.
Ryan, do you have anything to add about that?
No, it was a pretty good time had by all, I think.
Yeah.
Yeah, and I just had brought my. What else I brought something else. Now I suddenly can't remember.
Oh, I remember you gave us a
Oh,
little
I
showing of your
brought
program.
the keyboard, I guess.
Oh, that's right. You brought
Oh,
your
yeah.
little keyboard, the miniature or the mini sized.
That I've done the keycaps
Oh
on.
yeah.
Because I had it for mechanical keyboard nerdery, but I was wanting to get like a dedicated keyboard for the emulator. I thought about putting stickers on that, and so I said, well, I'll just get some of the blank keycaps and put those stickers on those keycaps, and replace the ones on this, and that's been working okay. You know, the stickers aren't the greatest. I initially tried. I think I showed Adam my attempt at putting some clear stickers over the Pi keys and markering on those, but that was all wearing off, and it wasn't going to work.
You and I are using the same stickers, right, from the same place that we ordered them from.
For
Online?
keyboard
Yeah.
Outfit.
Yeah.
Yeah.
Okay.
It's just that, you know, they're trying to put everything in on the key top.
Right.
Whereas of course the original's got some of the stuff on the top and bottom of the key. So I thought, you know, I think I mentioned, we talked about how it'd be nice to have a sticker set that had some of those words broken out onto separate stickers, so you could put them on the front of the keys like I did for the medium marker keys that this keyboard has.
Thanks for that link, David.
As a way of making, then if you had a version like that, you could make the printing on the key larger for the few keywords instead of having everything crammed on the one key.
Right, because it's very hard to read them. I always have to wear my glasses nowadays almost, but I have to really always wear my glasses whenever I'm typing on my keyboard. Like I mean, I have to on the actual real 2068, but it's much harder to see the keys with the stickers on it on my on the keyboard I didn't make the keyboard, but
it's not really a problem if you're nearsighted.
Well,
you can see those things, you know, even at 50 years old, I can still see those things, not a problem. I can't see the stop sign down the street. I need my glasses for that, but
So Adam's going to make a large
gonna do
print
what?
keyboard with each key being 1 inch square.
Mhm.
yeah, I think David will do that before I do.
Like those
So-
big button calculators, you know.
So those stickers, they come from a company called 4Keyboard, which is literally just down the road. It's up in Niagara Falls. It's about 20-minute drive from here in Buffalo. And Adam, you did a set of stickers for the Atari, right?
I did a set of stickers for the Atari. Well, yes and no. Like, so they worked with me. So I asked them, because I bought the set that they have for the Commodore 64.
Yeah.
And I really liked it. So I asked them if they ever plan to make one for the Atari, and they said, nah. I'm like, well, if I work with you or show you what you need to do, will you do it? And they're like, well, okay, yeah. And like the next day, they were done with it. And like I was like, what? And like they just wanted to know what keys they needed. And then I think they sent me a test one. And then I was like, perfect. And so the design of it, like if you buy the Atari one, like it's laid out for the emulator I use. So all the keys that are blue are for the emulator Altera that I use. But
Yeah.
so some people don't like that, but I got to help design it. So I like it. It works for me.
And so this I actually have a couple of these sets. The Sinclair set comes with keys for the if I recall correctly, the ZX80 and the 81 and the Spectrum. That's right. Yeah, from left to right is I'll put this up on the screen here. Here we go.
Yeah, I think there may be even some for Spectrum variants, but I don't know.
Yeah, so on the left-hand side, this first block on the left is the ZX80, and then the middle is the EX81, and then the right is the Spectrum. And you can either use the crazy colored, ones, or you can use black ones. But it's a nice little set. And there's a guy in, where is David Stevenson? I want to say Australia, but I might be wrong. He might be in New Zealand, who designed a external keyboard for the 1000 or ZX81. And his website is zx81keyboardadventure.com or something. And so when you buy or when he was selling them, when you bought the keyboard kit from him, he sent these stickers. So I did, and you know, I got a set of stickers that went all the way from Niagara Falls to the Southern Hemisphere and back.
Well, I know Ryan also showed off his 1000 mechanical, a little tactile keyboard you brought over too.
Oh yes, the micro switch one.
Yeah,
that I got.
Is that
Yeah.
is that the one that Stewart sells, or?
I think I didn't remember that or didn't know that, and I've gotten it from overseas
Oh, okay.
on eBay. I think.
Yeah, I
Okay.
think it is the one that Stewart sells.
Oh, cool.
Yeah,
Okay.
I actually
But it's-
forgot.
I'm
We
sure
did a
it's the
lot
same
that day,
one.
man. We really did.
yeah, because I think Stewart was importing them from them.
From Ginger
Um,
Electronics. In Germany, sold by Ginger Electronics. That's where I get them. The key-
Oh. None of the ones I've seen, they were somebody in the UK, because they also do like the RGB backlit keyboards for the Spectrum, the rubber keyed ones. So
Yeah.
they made a new overlay that's kind of, I guess it's transparent to light, right? And you can make it in different colors, and then the LEDs light up from behind it, and you can, have a fancy looking CX Spectrum with the lighted keys. But I think it's the same company, because the same basic principle. They use those really thin, tactile keyboard or switches, and then they put like little RGB lights above them, so that you can actually individually change the colors of every key. I think that's on the 40 keys,
Yeah.
and you get a
This
bit of
is
a
where I got it.
Oh, let me spotlight you. There we go.
Germany
Variable.
PCB for
Maybe-
DIY. It's not really focusing too good, but it does say Germany.
Yeah, maybe it's somebody who. Yeah, I don't know if it's what was the outfit you said?
Ginger Electronics.
Yeah, so this must be somebody else that resells them in Germany on eBay.
Did you put it up again? Let me just see.
There we are.
Hold it closer to your face, Ryan.
He-
It'll work better. probably.
Thomas
Yes.
von,
Hassian? I don't.
maybe.
Does it actually use micro switch brand switches? Do you know?
Well, you can't really tell because the keyboard's assembled, right? So
Oh, okay.
you'd probably have to peel the overlay off.
Oh, here we go. It the branding on the back.
Oh, yeah, that's it.
There it is.
Yep, that's the one I'm selling on eBay. Yep. Yeah, I just got, my friend goes to Germany to visit her grandchildren every 2 months. And she's my courier. So we don't have to worry about, anyway.
Shipping, huh?
Shipping with DHL or something like that.
Unfortunately, they ask her, "Ma'am, would you please step out of line?"
Yeah, there's a
Out of
whole
the
show
line.
about that, Stuart.
They couldn't ask her anything, yeah. And
Retro
and if they
computer
did, she
mule.
wouldn't even know what to tell them. I'm quite sure she doesn't understand what it is. I've tried to explain it to her, but she
Yeah.
doesn't quite get it.
Ma'am, did you pack this bag yourself?
Honestly, these nerdy things are not mine.
Right. I don't know how this got in here. Hey, so
Yeah.
Ryan, you and Jeff and um, the other Jeff is the other Jeff who's on tonight, is that Jeff K or is it a different Jeff? You guys made a bunch of progress over the past week, a couple weeks rather, in terms of making turning a basic program into a ROM EPROM capable image. Jeff, you want to talk about Python? Because we know how much you love doing software.
Well, Ryan had apparently, had originally talked about writing a program to allow making a basic program into a cartridge, which I didn't see. So I decided to go trundling off on my own and write a program. I decided on Python mostly because it's cross-platform enough, so it should work for Unix, Windows, and Mac computers. And I'm not using anything really esoteric in terms of libraries or whatever. So I have two different versions of the program. One is a command line version, which basically in Windows, you can just drag and drop a tap file into or onto the program. And it takes if it's a tap file with multiple files in it, it'll take the first one and assuming it's a basic file, it'll convert it to something that has default values and makes it ROMable for an AROS. Then I also wrote another program that, and that same program will actually allow you to import a control file that has a whole bunch of stuff in it that allows you to set up most of the parameters you might want to use to convert a basic program to a cartridge. Then I also wrote a wrapper using Tkinter, which is the graphical user interface, which produces some spectacularly ugly GUIs, but at least it's cross-platform. And that one allows you to set all of the parameters you might want in a GUI style, and then it'll save that out to a control file. It also allows you to load control files in and see what's in there. And then it also has the option that once you have a control file saved, you can go ahead and run the command line routine, which will then allow you to port. So it's a tool set that's probably mostly useful for the things that we were talking about earlier.
You're muted, David.
So Ryan, you were sorry, you were able to create a doc file from your program.
Yeah, so I used his Python version on, if I could run that on the Pi 400, and so then I was able to convert, make a doc file out of a program, and so then I sat down and started doing that, and I had to put in some debug to try to see what was going on in that environment. That's what I was, and it was, as I think had been said over the discussion emails, that basically, yeah, you're in ROM, except where I guess the practical upshot is I think it's copying lines from the ROM into the RAM to interpret them, but that's only piecewise. So yeah, the program as it wasn't seeing some bytes it was expecting as double checks for things like, hey, is there a rim line in line 1 that I can poke my stuff into? And it wasn't finding that, and some other things. And so I just changed it to where, as per suggestion, just poking the machine code into high memory. So in the normal machine, you've got the very top of RAM, you got the UDGs. So that's 21 by 8 bytes, and then and then the RAM top variable is right there. That's the end of basic. And so then my program normally then moves RAM top down 768 bytes and puts the font right below the UDGs there. And so I just have it say, well, I do some peeking and say, well, you're not finding the bytes that should be there. I must be a doc. That's my little cheap detection right now. And so then it just says, well, okay, we're just going to move RAM top down, some more bytes to accommodate the machine code, and that's where it goes. It pokes it there, and it just knows where it needs to be putting things. And so the machine code had already been made movable in that I had a couple of data bytes, so like the offset of the character it's working with. Originally, I had those as like bytes, and then the machine code would refer to that by a hard address, but instead I just use it in only one spot. So I just poke it directly in the machine code. So that was fine. It was just, it needed to store it in a real place in that environment. And then it was fine. So it kind of does both. So
Ryan, I have a question there.
Yeah.
Your program is now, it's compatible to run from a cartridge. It's compatible to run from tape in Spectrum mode, and also compatible to run from tape on the 2068, right? Is there any other modes it can run in? I mean, I'm not joking. Am I missing any?
Well, I guess, there's the OS 64 version.
Oh, well, okay. So 4 modes.
Which I'll have to update, I guess I don't have to update, because I don't think you can run that together as a dock. So so it still maintains that in regular non-dock mode, it'll put the machine code in line 1 rem. And I was leaving that for now, thinking that, well, because the idea was that when you edit a font, you could just clear the program out, and then all you're left with is font memory. You don't have other machine code hanging around. But in a dock situation, it's your ROM'd anyway, so it didn't matter. Because you got to pull that out to do anything else. So far that's and I was still, that's on the version I'm working on. So the thing I posted was kind of a beta version of that so far. I was gonna try to sew up some of the other features, and then put that out again.
Cool. Is your program so big that you couldn't always just stick your machine code above RAM top? Like even if it's running in the, from loading from tape?
Oh no, the machine code is not very big. It was just that originally I had kept it in a rem statement, just because that if you were done with the program, you could just type new.
Yeah.
And your font would be there, but there wouldn't be any residual machine code that you'd have to try to get rid of.
Right. Okay.
But when it's in a cartridge, that didn't matter. So I left both in there. I could just trim it down to doing it the one way, and I guess that would make it a bit smaller of a program, which I was trying to do, because I know Adam was trying to load off tape, and it was taking longer and longer because it's now twice as big as it originally was. But I figure, well, with a doc file, maybe that would finally fix it with him in the back bit. You just bam, and it's going. But
Ryan, you don't have to worry too much, because over the last week and a half, I've been using my Astrocade a lot, and I've been using it with the old 300 baud interface from 1978, which loads well at 300 baud, and so it takes to load a 1.8K program. It takes about 3 minutes 20 seconds. So it takes a while, and that's not even 2K. So it's like the 2068 is super speedy. Okay, super speedy. It's like a speed demon.
Doesn't the 1000 have that beat with like 150 baud or something?
I don't. Yeah, I mean the one. Well, okay.
Or no,
so
maybe it was 250. I can't remember the number.
Yeah, I think it was like 250, and it would take quite a while to load, a 16K program, like 5 to 10 minutes, depending upon the program. Yeah, I do recall that.
Yeah.
So you don't have any defined functions in your program, right? like DefFNs.
Oh, I remember you mentioned that. That was actually a question of mine. I was going to ask
Yeah.
people in the group. Was like when I was thinking back, I thought, yeah, it had that feature. I don't think I ever really used it that much. It was kind of cool, but never wound up using it all that much. But you were saying there was some issue.
Yeah. So
having to do with the cartridge.
off the top of my head, by the way, so it boils down to the way that a program runs. A basic program runs from the cartridge, and you mentioned this, that the interpreter goes through and finds that line of code in the ROM and copies it to a specific buffer in RAM, and then interprets that, and then goes and gets the next one, and so on. And defined functions rely on having access to the entire program in RAM, because when it hits a line with that function, it needs to go back up to wherever the function, or forward to wherever the function is defined. And there's not really an easy way to know that, because and this is the reason that people would stick the function definition at the beginning of a program, is because when Sinclair BASIC hits that call to that function, it starts scanning the program from the top down to look for the definition. So if you stick it at the
Isn't that
bottom,
the way GoTo works too, though?
so same way, yes.
Yeah.
It just starts at the stop.
Yeah, that was actually that issue in general. I remember somewhere hearing about where it was, it doesn't make some, as you would now, some sort of table to jump these, because you couldn't afford all that RAM. RAM is precious. Jump table would be a luxury.
Yeah.
And as Yorkshireman would say, and so they talked. I think there was some interview, and I guess I guess it was the guys at Nine Tiles talked about that from when they went to Spectrum. I think it was when they went to Spectrum BASIC, or possibly the QL, for the QL, that, well, now that it was going to have so much more memory, they were like, well, the searching thing was fine when you had a few K, but when you had like 48K, it could potentially be make it pretty slow, and that they might need to revisit how they were doing that. But with Sinclair, they were like, no, it's fine, just leave it. They didn't want to spend time redeveloping that. And so that was always kind of a weakness.
Fourth, got to go with fourth.
Speaking of which, when on our last Sunday meeting, Jim Marsh joined us, and Jim is one of the authors of this Timex. I don't have it handy. Timex Sinclair.
David, could you take off the spotlight off of Ryan?
Oh, I'm sorry. That's right. This Timex Sinclair Encyclopedia book, which Adam got from Interlibrary Loan once, and it's only 3/4 of an inch thick, and for the time it came out, it was certainly encyclopedic. Stewart has referred to it as a Jeopardy-like format, where the answer is almost as long as the question. So it has lots and lots of definitions of programs and hardware and etc. And then after the name of the product is up to 20 words. Is that fair, Stuart? About 20-25 words max per product, it seems like.
Yeah, the format is really unusual. The definitions are so short and intriguing that they almost are a question. It would be a quiz game to say, oh, here's the read the item and then say, well, what are they talking about? But there's many items, and it is, and some of them are very interesting. Yeah. So Jim, I believe in the process of compiling this book, he got some stuff. People sent him things, right?
And well, one of the things that he had was Treeforth, which was this replacement ROM for the ZX81/1000. And it actually had an extra socket. So you would take out your Sinclair BASIC and you'd stick this thing into your computer and stick the Sinclair BASIC into the other socket. And there's a little switch that you could mount on the bottom of your computer or something. And he had not one, but 2 copies of the manual, 96 pages on how to program, in an 8K fourth on the 1000. So I'll be digging into that. I uploaded it to the archive too.
So David, what was the name of that microcomputer over in England that used
The Jupiter,
Ford-
Jupiter Ace.
Jupiter? Yes.
Yes.
Yeah. So does it make it in a way sort of similar to that, or is the fourth totally different?
No. Yeah. It was similar to the Jupiter Ace in terms of,
Okay.
that they both used fourth, and, this was a cheaper failure to buy than the Jupiter Ace. Less expensive. And I found out there was a product sold in the UK by someone over there, and called Husband Forth. And according to
Is that just
the
me running back and forth to get something from my wife, or?
no, that's a honey-do list.
Okay.
It's not a Zsa Zsa Gabor thing, right?
Exactly.
Fourth husband. Fifth husband.
So this Husband Forth bears a striking similarity to Treeforth. I mean, there's a couple small differences in the ROM, and I looked at the manual, and there's a couple small differences in that, but the screen captures are 98% the same, except screen captures. The photos of the screens are 98% the same, except for some very minor changes. And the folks on the Sinclair ZX World forum have had discussions about the nature of that similarity over the past several years. There's some speculation. Let's put it that way.
So which
They-
one would be the one that was first then? Would it be the Husband Forth or the other one?
I suspect it was the Treeforth
Oh,
that
okay.
came before the Husband Forth.
I would think the first husband was first, right?
Right. Yes. So, Tom, are you there?
Yeah, I'm here.
Tom, talk to us about interpreting the 1000 in Lisp.
It's actually been a lot of fun. So far I've built the REPL, which I'm not sure if everybody here knows what it is or not, but it's
No, go ahead. Consider us to be Lisp neophytes, because
So-
everybody is.
so in Lisp, the way you program, it's very incremental, and you work in what's called a REPL, which is a read, eval, print loop. It's basically what the Timex Sinclair 1000 was, right? You could sit there and you could type print hello world and it'd do it, or print 1+1 and it'd do it. Or you can write code, lined code. And so in a way, it actually functions a little bit similar to the way a Lisp REPL does. So I created that, and I started creating the translator, and all I've got done in the translator thus far is the print command. But I spent a few days trying to figure out how to do tabs. So like you do print tab 10,
Mhm.
and then a word, so you can make columns. And that was actually really tricky to figure out how to do that in a terminal, because you basically have to track where your cursor is, what words have already been printed, and therefore how many spaces you need to get to the next tab position. And you got to keep a running list of that. So anyway, I figured that out and got that working nicely. And next on the agenda is goto. I'm going to try to get goto, let, and maybe input, and just try to get it a little bit more interactive. So hopefully by the next meeting, I'll have that done, but it's actually going really well. it's kind of a fun project.
That's
And it's
cool.
really, I think, relatively quick to program in Lisp. Lisp is pretty simple language in a lot of ways.
Is that Lisp an interpreter or is it compiled?
It's compiled.
Okay.
Yeah.
Because Python's an interpreter and
Yeah, so if you compare, I program in Python as well. So if you compare the speed of Lisp to Python, at first glance, they seem pretty similar. But when you start getting into nested loops, especially if you nest 3 deep, the Python really slows down. Lisp just keeps right on kicking. So it's Lisp is really good for layers of code, I guess you would say.
Tom, are you aware of Ian Logan's ROM disassembly for the ZX81?
The name doesn't ring a bell, but it might be
Okay.
what somebody posted. Did you see? So I posted a little quick video on the forum there on the group.
Yeah.
Somebody replied with a simulator of Timex, which is really helpful because I have a hard time remembering exactly. I kind of remember how it all worked,
Yeah.
but I've got a lot of gaps in my memory. So that gives me a way to sort of test that what I'm creating actually
Does the right thing.
functions.
Well, so you mentioned, tracking the cursor position, and that reminded me that there are variables in, Sinclair BASIC for both the horizontal and vertical position of the cursor, which is well documented in that book. I'll dig up the URL and put it in the chat.
For like plotting and stuff. Is that what you're
No, just for the cursor.
Yeah,
for
There's a number of.
there's a bunch of
You can find it
variables, but
online, different places.
okay?
but yeah,
But
I'll
yeah,
find-
I mean, all in all, it's going really well. I'm kind of, so I've got a couple little Easter eggs I'm going to put in it because I just think it's a smart idea. One of them is I'm going to have a mode on it where you can put it in test mode so that if you end up in, say, a go-to infinite loop on accident, that it'll only run that, say, 1,000 times, which with the speed of this implementation is just going to take a few seconds, right? But then you can turn that off or just not enter that mode, and then it'll be more realistic, I guess. And the other Easter egg I want to put in it, but I need to get a few more a little more functionality, is I actually, I want this to be kind of fun and easy, but on the other hand, it would be really cool if it was useful. So I've also programmed it so that you can pass it when you run it. I can compile it. I've got it compiled as an executable on my computer, and I can actually pass a program to it in the terminal, right? And so it'll just take it and run it like a script as well. And I'm setting it up so that it'll create a return value. I need to come up with a command for that where I create a return value so it can return a value to whatever the program is that launched it. So in other words, it could even be used as a little scripting language just for the hell of it.
What platform are you developing it on?
I was developing it on Windows, but my Windows computer caught on fire. So now I'm developing it on a Mac. I went out and bought a MacBook Pro because I've never had one, and I'm really enjoying it. And for those of you who are dying to ask me about Linux, I actually used to be a Linux tech support engineer, and so I don't really use Linux anymore, but I'm very familiar. So anyway, yeah, right now I'm developing it on a Mac.
It's a form of Unix under the hood. So
Yeah.
So Tom, what
Yeah,
inspired you to start this project? And why Lisp?
I don't have my little book, but I ran across the little, so there's two questions. I ran across my little Timex user's manual on Amazon, and I just bought it because it was just kind of a sentimental, nostalgic purchase. And then I thought, you know what? It'd be cool if I had like a little easy version of that just to kind of use and play with, and even maybe make it kind of useful. And so I decided to go ahead and write an interpreter for it. As for why Lisp, the only thing I know to tell you guys is Lisp thinks the way I think, right? It just,
Oh my.
it feels right in my head so I can just pound out code. There's very little syntax in Lisp. So it's, if you understand how Lisp works, it's hard to beat it for a fast prototyping sort of language. So it just thinks the way I think. It just kind of comes from my head. It's easy.
Tom, I admire it. I remember back in the 80s reading. Now maybe my choice of reference material was poor. I remember reading a tab publication about Lisp, and I don't know if any of you guys remember tab books, but some were good and a lot were just terrible.
Not good at all. Not good.
Yeah, there's actually I'm not saying it's becoming popular per se, but there's a bit of a resurgence of Lisp. Like if you go on Reddit, there's a Lisp community. I want to say it has like 13,000 members. And there's a very, very high knowledge level. Like I go there to ask questions and stuff, and the level of knowledge that I get is just crazy good. Then
Wow.
there's a new programming, well, it's not super new, it's maybe, I want to say 10 or 15 years old, but it's called a Clojure, Clojure. And it's a flavor of Lisp, and it actually is pretty popular in some circles. So Lisp is still around. It's not, it's like I know people that are actually still using it for prototyping and research and development. So I mean, it's still being used, but not in massive numbers, right?
Yeah.
But I don't know. It's a surprisingly good language if you take the time to get through. There's a book called Practical Common Lisp by Peter Siebel, I think his name is. And if you can get through the first 2 or 3 chapters, you'll be sold on it. It's just really good. But it is, if you're used to traditional programming languages nowadays, doing something like Lisp that really has very little syntax is it doesn't necessarily make sense until you start figuring it out. But once you figure it out, you're like, holy crap, I can do in one line of code what most programming languages would take a couple of functions to do. You can just, it's pretty crazy.
Is Lisp more like a functional language rather than an imperative language?
So it's so what I use is ANSI Common Lisp, which is like, the cool thing about it is if you, like, I've literally wanted to know how to do something in Lisp, go on the internet and find a post that's like 10 or 12 years old, and it still runs on it, right? It's standardized. But it is ANSI Common Lisp it's multi-purpose, general usage, and it's mostly functional. But it does have very strong object-oriented capabilities, although they seem a bit dated compared to modern OOP. So, but I program functionally. I hate OOP. It's mind-boggling to me. But functional stuff, I can just pound it out. So, but yeah, it's a very powerful functional setup.
What does LISP stand for? I'm sure it's an acronym for something, right?
List
Language.
processing.
Yeah.
Everything in Lisp is a list. Everything. And I think that's one of the reasons that early on it was like the primary language for developing artificial intelligence.
Yeah. I mean, I remember that being the big
I'm
deal.
not sure if that's the case anymore. I doubt it.
Cool. Very cool. Thank you, Tom.
Sure.
Stewart and Tim, I bet you guys have been up to stuff.
Yeah. I seem to be the more talkative one. Tim is the doer. But I'll give you an update on where we're at. I'm pretty excited about it. I have to thank both Tim and David for mentioning that they're using Easy EDA for their printed circuit board designs these days, and for parts for manufacturing boards, both bare and populated. So I've been starting some other projects with that, and getting back into a makerspace head, which have not had for about 4 years. But now I build something and I say, but I don't have a laser printer. How can I live without a laser printer and all these other things, 3D printer? And so I think I have to rejoin my makerspace as well for these projects. I'm going to share my screen because I think that's going to make it easy. Am I allowed to do that?
Give me a sec.
Yep.
There we go. All right, you should be able to do it.
Okay, so I'm going to share this screen because it'll be a little easier. Okay, so anyway, this is just I tend to keep my notes on a website, and because I'm a Joomla developer. So I've been thinking just today, well, what's happened is Tim had the board working for himself. He describes himself as someone who likes to make things for his own usage. I am his first user other than himself. And I also tend to think about how we're going to communicate to the rest of the world what this product is, and so that people will try it out. And we both have the goals of both, in this case, driving the existing Timex 2040 printers and the AlphaCom 32 printers, as well as the original Sinclair printer that printed on silver paper, which I've never seen, and is not very popular in the United States. However, the interfaces are very almost identical. So anyway, just today I said, well, so anyway, Tim shared his design for the board on the Easy EDA platform, and I just ordered 5 from China, and like in no time at all, it seemed to me, I had boards, and I just put headers on it to stack this board, which is an Arduino shield, on an Arduino Uno, and it was up and running in no time. Then I got to thinking, so here, if you're looking at the screen, here's a AlphaCom 32, and this board, the top one here, is the first version of that board that we're calling a DX printer shield. So the way it works, I just drew this diagram today to try to explain it. So the printer shield goes on an Uno. It wouldn't be much different to go on some other, for it to be a shield for some other processors. We'd have to check the pinouts, and maybe if the pinouts aren't a contradiction, just maybe some switches in the software. The first things that so anyway, here's a picture of the boards. So you can see this edge here just plugs right into the printer. You socket in the printer. Here are some headers. These happen to be non-stackable, but after I built the first one, non-stackable, I realized, gee, there's a lot of unused pins for connecting things to this Arduino, like a real-time clock, if I wanted to log data, temperature, humidity, or contacts. Or today I thought of, oh, if I added like an RFID card input, you could do a time clock. People could use their RFID to check in, and it could, with a real-time clock, it would have the time, and it would just print it out. And in some jurisdictions, having that paper makes your time clock legal. They don't trust all electronic with no recording on paper. And there was one resistor for this. This connector here on the left is only because if you have the original Sinclair printer, it needs a different power source. Here's like the tops and bottoms of the board. When I first put mine together, I didn't literally have a resistor. So I used a pot, but that just used to be a resistor. Anyway, when I thought of building my first projects for this, I said, oh, I'd like to stack another board, like a proto board, you know, an Arduino Uno prototyping shield on top of it. So, but I didn't have stackable headers. But anyway, when they actually market this thing on eBay and make it available, it'll come with stacking headers. So on the header, the first thing I did is take a real-time clock, a temperature sensor, and, you know, have it log data. So here's, it had some sample, Tim has taken the software and made it pretty much a standard library. So you can, it easily installs in with the Arduino IDE as a library, and like a lot of common libraries, has some examples. So if you just want to print hello world, you can load that. If you want to print some characters out in a font, you can easily do that. And if you want to print some simple patterns, like if you want to easily echo the dot patterns for a row, there's a driver for that. I requested it'd be nice. I said it'd be nice to print graphics, and like a day or two later, he came back, and yeah, here's an example of some of the three built-in samples. Hello world, printing out some character set and printing out kind of lets you plot a line very easily, so you could do, you know, simple blocks or whatever you want to. That's not particularly relevant, but if you want to use these proto shields are like $2 on eBay. So if you want to prototype, that's useful. This was as soon as he did the library to print an image, he printed the first one, and I just downloaded an Arduino logo, and it didn't take very long to print that out. So if you want to do graphics. So anyway, the minimum you would do is you'd have the shield and an Uno connected to your printer. And of course, if you do that, you know, unless you have some inputs and outputs, it'd be pretty boring. I guess you could theoretically have your program load, turn it on, and it would just like print something every hour or whatever. But most likely you want switches as inputs or sensors or something like that. So here, optionally up here, you would have the sensors and, you know, on the unused Arduino pins and what little memory is left. You could write your code and go directly to that. So you'd have 3 atoms. Optionally, you could use the shield, but also it does need a power source. You could either use a little, you know, cube like for your phone and give it 5 volts through the Uno's USB connector, or you could use a computer to supply the 5 volts, as well as you could communicate from a computer to it. Now, we haven't finished this. He hasn't finished the software, I don't think. He'll give you an update. But the other way to use this is not standalone with the only processor being an Uno. You could use a Raspberry Pi or another Arduino or a microbit or an ESP266. The idea is that, you know, this is for makers. These days, more makers are playing with Raspberry Pis and Arduinos and whatever. So why not have it benefit from connecting to this computer? So anyway, to this printer that they have around. So anyway, that's kind of where it's at. Oh, also, when I started to say I was adding things like a real-time clock or some I2C or sensors into this, I found out how dated I am by not being in a makerspace for 4 years, playing with electronics. So Tim just said that this quick connector has become very popular for sensors from companies like Adafruit. Adafruit's kind of our, we both admire them immensely. We'd like to make this kind of like the way they do, an open source project, an educational open source project, as well as just letting you print. So we're trying to document it. I'm trying to document it kind of the way they do. But at any rate, I just actually got today from China my first cables that go into that little quick connect thing. So I'm used to like JST connectors, and I thought they were small, but these things are on 1 mil spacing. I just haven't, I don't know how they do this in practice, but so you get a four pin I2C compatible connector, and we put that on this printer board. So it'll make it even that much easier to interface to sensors and things like that. Tim, you want to take it away and say anything more?
No, Stuart, you've done a great job.
Anyway, I think, what are you on your, what's the status of the last go around of the board, time-wise? You didn't receive the third one, right?
No. I'm trying to get the I'm trying to get the Windows printing from Windows all buttoned up, and there's a couple of tweaks. So yeah, almost there. I'll send it off in the next couple of days.
Right. So basically, the board worked fine, the first version, but soon there'll be another go round with China to New Zealand. It's 17, or now with daylight savings time, I think 18 hours difference. So Tim is just about 4 o'clock there in the afternoon for him. He's in the middle of a workday, actually. So I wanted to get this discussed. But anyway, one more go round on the circuit board, and he'll just test it there. And if everything's a go, I'll order a batch here. And if there's anybody in this group, you'll just get me your address, and I'll mail you some boards that you can, a board that you can play with your printer. And the documentation, the software is on Tim's Git repository. And I think it's going to be a lot of fun. So that's coming. I started another project, much simpler, but I needed some, I hope that this project is the first of several. The obvious thing to work on, now that Tim knows and intimately understands the timing of the printer interface, what is the ZX81 providing to the printer? What does the printer need? So the obvious thing to do is take that knowledge and you come up with a board that talks to the receipt printers, modern receipt printers, like the one that Adafruit sells. And to be able to talk to that, if you don't have a printer for your Timex machine, you could go to that from your Timex. It's kind of the reverse. And that would actually be a little more benefit to the Timex users community. This product principally benefits makers who happen to have Timex printers. It lets them use it. But once you understand the interface, it makes sense to kind of like use that knowledge to go in 2 directions. I have another project. This would probably be my first printed circuit board in 4 years. You're sending out. Since I like those keyboards, these little tactile keyboards that I am importing from Ginger Electronics so much, and I happen to have a lot of Timex shells, totally empty shells. I'm designing a little board. This is a dump of the EDA layout that I'm just using to get my 3 screw holes so that this thing properly mounts in the ZX81 shell. And so normally there's a board there, obviously. Yeah. Normally you've got a well-populated PC board, but I did this to get my whole locations. So basically, I'm gonna have a simple board in here for use with emulators, just to turn the keyboard, which I really like the feel of, and it has that authenticness of layout. It's not a big, 101 keyboard. Everything's in the right place, but it feels good and functions well. So take that, and instead of feeding a ZX81 board, this is just going to go to a Arduino Pro Micro to convert it to, it'll look like a keyboard to your PC.
Like a USB keyboard, is that what you mean?
What?
It'll look like a USB keyboard?
Yeah, it'll look like a USB keyboard to your Raspberry Pi or your Windows, whatever's running your emulator. And the other thing is, this is to add while you're at an Atari joystick connector, so that you'll be able to play the games with an Atari joystick. So it's very kind of low tech, not a lot of software involved. It's a very simple program, but that's kind of the first thing. On my list in parallel, I want to come out with, I plan on coming out with some boards, or not even necessarily selling them, putting the designs for boards that implement the projects from several of the old books from the 80s, the hardware books, like the ins and outs, or there's a book on interfacing to the Timex 1000 ZX81. So they had products, they had the plans in those days, mostly to go to either low power Schottky TTL devices or parallel peripheral interfaces that were designed for the 8080 in those days, or Z80. But the documentation and the tutorials exist in these books. So my thought is to have a breakout bus, and you could plug these. The individual boards wouldn't even need, they just have edge connectors on them. So once you have a little bus expansion unit, like the one David sells for the 2068, you could either use that on 2068 or a narrow one for the ZX81. And people could use these things to play with and add things. And I especially want something that bridges to the Arduino and kind of protects the bus. Anyway, that's
so Stuart, I have a question for you. What year did you get out of
Zebra?
Well, you got out of the Timex world and you did Coco for a little bit longer, but what year was it that you stopped? You sold all your stuff to Rod Gowan, right?
No.
Oh, I thought you did.
No, what happened was I was operating in 1983. I took a little storefront in Queens, and I had 4 employees, and Al Hartman was one who helped with communications and ran a bulletin board in the off of TRS-80 in those days before the internet. And Tom G helped design hardware and certainly build the prototypes, and I designed hardware as well. Jeff Street did software, and 2 women fulfilled orders. Ads in Stink magazine. The checks came in after a monthly ad appeared, and they did the fulfillment, and UPS shipped it out. So what happened is, as the Timex dwindled, we did some things for the Radio Shack color computer. I was in the habit of buying surplus stuff. I bought, I don't remember how many thousand trackballs.
Yeah, that's right.
And we modified them. they were surplus for some computers, and we modified them to go on the Atari and stuff. And when it became non-profitable and didn't look like a good future, at least not for that staff of employees doing what they did, I closed it. I moved out to Pennsylvania because my brother had a store there with some space.
Mhm.
And we continued modifying. I had a full-time employee modifying trackballs for more than a year out there.
Wow.
Anyway, I had all that stuff. And after a while, my brothers downsized into a different building. So the oddest thing was in 1988, I bought 3,200 CX81 kits, which filled 2 garages. And then it kind of ended. It just, I came back to New York. The stuff stayed stored. Couldn't sell it. There was no internet.
Yeah.
No more magazines. And I just did computer networking, and the old people remember the beginnings of eventually Novell networking, and then
Yep.
Windows networking, and then later than that, designing websites. And in 1999, I started selling those kits, mostly the kits and the books, on eBay, and I'm sort of doing that now. But I didn't play with any of these devices.
Right.
I turned on a 2068 last month for the first time in 20 years, 22 years. Yeah. And yeah, when I unboxed it, it said check 2000, April 2000. Okay. And I bought David's adapter, which really helped the color on my monitor here.
Did you
but
get the
now I'm
RGB
in-
adapter?
Huh?
Did you get the RGB adapter?
Yeah, with the Sega.
great.
Yeah, it works
That
great.
thing's awesome.
So anyway, so now this is a different mode. It's partly because the kits finally got out of the way, and I'm kind of looking at this miscellaneous leftover stuff and saying, and it's an excuse to get back into,
Yeah.
making stuff. Yeah.
Yeah.
So
30 some odd years later.
Yeah, I have these shelves. I don't know how many I have of stuff. Because the stuff is stored, some of it in the crawl space under my summer house.
Oh boy.
Instead of having normal shelving where you could just say, put everything in order and count it accurately, I don't actually know exactly what I have, but it's on the order of 35 kits and I don't know, maybe 30 to 50 assembled ZX81s that were supposed to be kits, but when I took them out of their box, one cube of 33 was not kits, it was assembled. And then another box of 33 that was supposed to be kits was empty shells with just keyboard memory. So it's this miscellaneous stuff that I have left that I'm playing with and having a good time doing it. So
That's cool.
Pops up.
That's cool. Hey, so Ingo and I chatted yesterday for a while. Time ran away from us, and Ingo showed me his little IO board. Ingo, can you show everybody else your IO board and tell folks what you've been doing?
So let's see here. I could probably show it best if I share. So what I did is I have a scratch built computer that I've been playing with, and I most recently needed some parallel ports on it. So I let's see here. Here we go. Here's some good pictures. So what I
Screen
did.
sharing. Are you trying to screen share?
No, he's trying to find the pictures.
Oh,
Yeah, I had to find the pictures so I can share them. So let me. Here we go. Share screen. And let's do that. Okay, so this is a drawing, my schematic and the wiring on the back. I've got more of a zoomed in. Let's see here. Wait a a minute. Here we go. This is the wiring right here. It's all so my whole kit computer is using the Euro card DIN, was it 41612 connectors.
Okay. Yeah.
And so that's the solder side. This is the component side. So basically, I've got two Z80 PIO chips. So each one of these provides two parallel ports, and they're really flexible. You can do a lot of neat stuff with them. They're a lot like the Intel 8255, and but they're obviously made specifically for the Z80, and so they can do the whole daisy chaining, interrupt chain. You can do a lot of neat things with it. So I put these two headers down here to bring out port A and port B of each of these chips. So I've literally got 4 parallel ports on this card. And then the yellow and blue jumpers over here allow me to set the address ranges for them. So I've got one jumper set for basically address 0, 1, 2, and 3 for the one, and then the other one is 4, 5, 6, and 7. And then I did this because I'm messing around with decoding the Timex Sinclair 1000's keyboard, because I want to build that keyboard buffer. So I took it one step further, and then I built hang on, let's see here. Here we go.
Ingo, can I ask a question before we get too much further? Because I'm a little unclear about.
Yeah, please.
Yeah. So this is for the Timex 1000, right?
Yeah, it'll
and it's not compatible with any software. So any software that would use it, you have to write yourself, right? Like it's not like trying to be
okay.
parallel
So
ports
actually, no. All of this is for all of this that I'm showing you guys right now is for my custom computer, which I'm using to basically debug the ZX81 ROM routines for the keyboard scanning or keyboard reading or decoding. So yeah, I'm actually going to connect my ZX81 keyboard that I made, the mechanical keyboard. I'm going to connect it to my DIY computer, and then I'm loading an EEPROM with that keyboard routine, and onto the parallel port card, I'm putting it's a debug unit, right? So it actually, here, let me show a better picture. So here's this board piggybacked onto the parallel port card. What it does is it'll show the value of the accumulator and the value of the flags register. And I've got it, so it's triggering off of the refresh, the memory refresh signal off the Z80, so that after every single opcode fetch, it will output to these two ports the value that's in the accumulator and the value of the flags. And I actually have a little video demonstrating it. Hang on, right here. So this is it running. So this is my whole DIY computer here. I've got 4 digits for the address bus display. I've got these 2 digits here for the data bus display. I've got a bunch of these bar graph LEDs here that show the different control inputs and control outputs from the Z80 microprocessor. And then up here, I've got a value that's in the accumulator, and then here I've got the flags register.
So
and,
just looking at that, you were doing a reset 38, weren't you?
Yeah.
Anyway.
Exactly. So and the 38 is interrupt mode 1, right? So this little circuit that I have on the breadboard down here is basically just a 74 LS32, which has got 4 OR gates on it. I'm only using 2 of them. and I'm combining the refresh signal with mem request to trigger that interrupt. And so you can see right here, I don't know if you guys can read that. It shows the sign, and then there's some empty bits that are actually mirrors of the accumulator, and then your parity overflow and the half carry that just went off. So
do you have a way to control the clock? Otherwise, it would go. It's going slow enough to read it almost. So
yeah, so I actually, so if you look here earlier, see this knob on the side right here?
Oh yeah.
So I've got several different ways I can clock this thing, right? I can put it into just a single pulse mode where I flip a switch and it gives me one single debounce clock pulse, which is cool. You can do that with the Z80. Like it'll run with a stopped clock as long as you don't stop it in the, I think it's the low state. If you stop it on the high state, it's fine, it's happy, or it's the other way around now. I can't remember, but and then I have another mode where I can run it on this adjustable clock, which is just a 555 timer, where I just change the time constant. And then I actually have a 4 megahertz crystal in there, so I can run it at native clock speed. But then, of course, you can't see anything.
It was so fast. Yeah.
So right now it's kind of like a microprocessor trainer, and I'm going to use it to, as I'm writing my assembly programs, actually run them on hardware and be able to see. I want to be able to see, if I run a certain instruction, I know I can look in the book and see, all right, it's going to affect these flags this way. But I don't know. I wanted to see it. So that's what all that is. So the next step is to actually attach. Actually, so I already have the keyboard routine loaded on my EEPROM. And that's actually what's looping through there. It's just I don't have the keyboard hooked up yet. So that's next. And
you don't actually need a keyboard on a computer, Ingo.
But yeah, so that's been
very nice, by the way. Very nice.
That is ridiculously cool.
Yeah.
Thank you. Thanks, guys.
And another thing, Enzo, is some other people are doing this for some of the other processors. I think somebody else has it for the Z80, but a lot of times you'll get Chinese copies, right? Or you want to get a Z80 and they're kind of hard to get sometimes nowadays. So you'll get, hey, go to AliExpress or whatever and buy 10 of them for, $5. Some people are coming up with basically like I call them NOP testers. They just basically clock the CPU, Z80, and it just runs NOPs, right? So basically you can kind of gauge go, no go with that. I mean, the processor actually is working, but right. I would like to see somebody develop something a little bit more intricate where it actually runs some code, I would call it diagnostic code, but you want to go through all of the registers, you want to read them, write them, make sure that they read right, or you can write them and you read them back, they're what you wrote, right? To make sure that they're not, and some of these they actually have different speeds, right? So you can run 4, you can run 2, you can run 6, you can run 8. I think they maybe go up to 12 megahertz, right? So if you get a 12 megahertz Z80, you want to make sure it runs at 12 megahertz, or when it stops working, I guess you could, it still might work at 8, right? But it won't work at 12. So that, you've already kind of got a lot of the groundwork already set there, right? For making something that may be able to basically test, right, a Z80 CPU and make sure that it's fully functional or not. Right. So I know there's some other, I was looking at getting one, but most of the ones I've seen are just knob testers and speed.
Yeah.
Right.
The first incarnation of my computer, I was following the lead of a guy named Julian Illiot. I don't know if I'm saying his name right. He's on YouTube. Does really neat stuff. And some years ago, he did one blinking LEDs Z80 style, where he basically breadboards a Z80. And he puts in some pull up and pull down resistors and a 555 timer. And, and when I saw how easy that was to do, I was like, okay, this is actually attainable. I just got to put in some time and do some learning and do some studying and some trial and error, and because I thought I want to build my own computer from scratch, just from components. And right now I'm kind of in this microprocessor trainer phase, you know, like the ET3400 that I have behind me, you know, the Heathkit microprocessor trainer. I thought it'd be cool to build something in that stage first before I actually take it to, you know, a general purpose computer, general purpose micro. But yeah, it's just been a lot of fun, you know. The whole thing started on a breadboard, and at that point, on my data bus, I just had a bunch of pull down resistors so that I was running no ops.
Right.
And
So
so
that's what he does.
see,
He just says, yeah, he just has like the address, all the LEDs or all the address lines are hooked to LEDs, and then you can see them. You know, you can adjust the clock.
But yeah,
I mean,
the only thing you're seeing at that point is that you're having a successful fetch cycle, right? And you're watching your program counter register increment, and that's basically it. That's all you're doing.
Yep. And that's good. You know, like I said, that's a good basic test, but it would be nice to be able to check your registers, you know, put something in there, but then now you got to have software, right? You got
Yeah, but anyway, you know, if you build this tester with a ROM program on it that, you know, and maybe has some RAM on it too, so you can actually even have a stack and run some subroutines and make sure that it executes jumps and everything correctly, right? Conditional jumps, and that would be really cool. That's a neat idea. I hadn't thought about that.
Yeah, because I know they do it for some of the 6502s, and you know, but I still think most of those are kind of low level, right? They're just go no go techs, right? Because some of these CPUs are getting hard to get, right? And when you do get them, you can kind of get them from scrupulous sources, so to speak.
There's a lot of stuff, you know, I've seen a lot of YouTube videos where people are talking about, you know, getting these bogus or just low quality chips, you know, and all different, like just 74 series chips that, you know, they're stamped that it's this, but you know, you plug it in and it either works once or it doesn't work at all.
Right.
And yeah, there's a lot of that going on. A lot of counterfeit
Right. But I was just thinking, you know, you're kind of already, you know, laid a lot of the groundwork for a piece of tool, a test equipment tool that would be able to run the Z80 through its paces. That's all. So just keep that in mind.
Yeah, thanks. I like that.
Carl?
Ingo, this reminds me of in the 1980s, I believe, they had what they call an ICE, an in-circuit emulator, which people would use. Now you'd pull your Z8 out of a socket and you put it in the ICE, and basically the purpose of it was to let you control how fast it was going and see all the registers. You're sort of doing it now. You're not attempting to replace the Z80 functions.
Those were like thousands of dollars back then, right?
Oh, yes, they were.
Like many thousands.
Tens of thousands.
Tens of thousands? Okay. All right. Okay.
I'll give you guys. I'll sell them to you guys at 50% off.
I'm a little.
You, my friend, special deal. Special deal.
David, I know last time you didn't get a chance, and we're down to almost a half an hour left. And last time you didn't get a chance to tell us about your updates on your site, and you've made some significant ones, including I was hoping you'd be able to tell us as a group about your disk imaging and how successful it was. I don't know if you're.
Okay, so yes. So way back, Neil sent me a couple boxes, 3 boxes of those special 3-inch, what do they call them, compact floppy, I think, discs. And these were some sort of, you know, Hitachi made the drives, and they were kind of wacky. They were double-sided, except that, you know, in order for it to be double-sided, you had to eject it and turn it over and stick it in. And the discs are actually like labeled that way. So there's like an A on one side and a B on the other side, so you can tell which side you're looking at. And these were used in the floppy disk systems that Timex Portugal built and that Stewart imported. And so this friend of Neil's ended up with a pile of them. And then Neil ended up with them, and he sent them to me, and he sent me a couple Hitachi disk drives, bare disk drives, right? And I thought, oh, I'll get a Grease Weasel. And the Grease Weasel is this little FPGA computer device that you can hook up to any with caveats, I have no idea, but anything from a 3-inch to an 8-inch disk drive from, you know, the 70s forward, right? As long as it had that 34-pin connector, that interface. And then you hook up the Grease Weasel to your computer and you run some programs on your computer, and it will image the physical, magnetic patterns on the disk. And then there's some other software that you can use to like put all that stuff together and turn it back into a disk image. And this is really popular with the Amiga folks and some of the other old computers. So I had this stuff, I tried it. I don't know what I did wrong. Like maybe I tried to run it off a 12-volt 1-amp power supply, which probably didn't provide enough oomph to get the motor started. And then a couple meetings ago, 2 Sundays, I think, Johnny Red came on and showed us about this special version of Fuse that has an emulator for the FDD 3000 in it, and that can load these disk images that folks have made using a program called CPC Disk XP, which was written for the Amstrad CPC, but it also used those 3-inch discs, but also was able to image the Timex discs. And
Now,
I think,
was it able to image them on a logical level or like?
I think it reads the data off the disk as if, not a magnetic, but it doesn't do a magnetic scan, but reads it, as if it were like a DOS disk, right?
Okay.
And
What are we
Joe,
talking about here? The Grease Weasel program or the
CPC
emulator program? Okay.
the CPC program. And so Joe Van Zandy was on that meeting, and he said that he had some Amstrad 3-inch disc, that crazy Amstrad that was sold back in the 80s with the 2 3-inch disc drives and some other stuff. And so I connected with Joe and I sent the discs to Joe, and Joe did both of those things. He used the CPC program to read the things, and he also got per track images from the Grease Weasel. And then he sent those back to me, and I started puttering around with it. And I was able to extract, I don't know, 50, 60 programs from these various discs, some of which, I've seen before. If you want to play Star Trek on your 2068, we now have Star Trek.
Cool.
If you want to run a bulletin board system on your 2068, we got that too.
I'm gonna do that from tape, David, just for you, just for me.
Yeah. There's like 4 programs that people had written, 4 bulletin board programs, and this one was the one by, I think this was the couple in Cincinnati or Cleveland or something, and a bunch of other programs. And some of them are CPM discs, so CPM 2.2 for the FDD 3000. A couple of them were labeled as zebra discs. And what else was there that was of interest? Oh, right. A whole host of them were capital area Timex Sinclair user group library discs. So, user groups would put together program libraries, usually on tape, but then, when disk systems became available, they put they put their program libraries on disks. And so these were Zebra disks that had I think there was about 5 or 6 CATS libraries and 1 Cleveland user group library disk. So I've uploaded all those disk images to archive.org, and I said I was going to upload the files to a different place, but I also uploaded them there, so they're kind of all intermixed. But I will upload the files to another place where they're easier to navigate.
Yeah, I did download, like, and it's like a huge download. Like,
Yeah.
Because I think the raw files, each track is one individual file. Is that
Yep.
right?
No, so each file is one track. Yes. The
Well,
inverse of what
in
you
any
said.
case, there's like 2,600 or 8,200 raw tracks, and like I don't think there's anything we would do with them, right?
Well, I mean, if
We just use the DSK files, right? Or
yeah, I mean, I would just use the DSK files.
Yeah.
But I mean, there's a few disks where nothing shows up in. Johnny mentioned this other program called Tomato, which you can just run. It's a command level program. It's a DOS program. Is that a DOS program? Well, it's a DOS program, but it requires something about Windows. So I had to run it in Wine. It wouldn't run in DOSBox. But anyway, it's a command line program, and you give it some switches, and it will scan the disk and spit everything out, which is how I ended up, completing that task of extracting stuff. But there were disks where it didn't find anything, and I have not gone back to look at the the raw track files to see if there's actually something there. Like, I don't think it can read the CPM disks. I think it just has no idea what to do with those.
the software doesn't, but like the
Yeah.
data is there in the raw file, so someone
Yeah.
later can access it possibly.
Yep.
I
Yep.
see.
Yep.
So for ultimate archive purposes, gotcha.
Yep.
Well, the other thing too is, I have a Kyroflux, which is similar, I guess, to
Yeah.
a grease weasel, right? Because Kyroflux, well, the way those things work is they read the magnetic flux data that's on the disk, right? So that's how it gets its data. So it's really, format agnostic,
Yep.
right? Because it doesn't care what format the disk was written in. It just reads the magnetic data off the disk, right? It's up to you or some other program later to figure that out, right? How to put it all together into the program for whatever format that it was written in. But so maybe some of that track data is what you're saying is some of that magnetic data, right? And the other part of that is you can actually create a new disk. You can write that magnetic flux data back to a physical disk and recreate it. So that's another reason why you kind of want to archive that magnetic raw data as well, right? Is to actually be able to create a real copy on real media at some point in time.
Yeah.
If you wanted to do that.
Yeah.
Exactly.
Is that isn't that dependent on the track alignment?
Well, it really depends on the deck. I say the drive that you connect it to, right? Is it out of alignment?
Yeah.
Well, then you're going to get a crappy read.
Read.
Right. So, I mean, there's more than just, I got a Kyroflux or I got a grease weasel, I'm going to hook it up to a drive and read disks from it. You just got to make sure the disk is compatible with that drive, right? And that the drive is in good working alignment and condition, right? It runs at the right RPM and all that kind of thing. But once you get all those hurdles done,
you make it sound so simple, Carl. It's just so simple.
Well,
so yeah,
Carl and Ryan make a good point.
What I did here was like, depending on what you're trying to the disk you're trying to archive, because one of the things back in the day was that some of the drives could be through direct control be stepped half tracks, and this was a mechanism for copy protection. They would purposely make the disk, put the data track in half a step off, and that was the copy protection, and the machine code could read that, force it to read that track, and if you didn't archive it that way, you didn't get the real disk, all the data.
But Carl spent his high school years hacking that stuff, and so he can get around that for us.
Well, that was a
Well, I
laser
think- I think-
a laser burning a hole in the physical disk. That's what I circumvented. But
Well, I think that what some guy, I forget what it was, they might have been some Apple II guys, noted what they were, doing something similar. I think that one of the things he did was like he archived it where he was doing half steps or something like that.
Mm.
So he had all of that in between.
That interstitial
But
data.
Carl's right that probably normally, as long as the drive is in alignment with the track, and it's not a crazy disk, then you're good to go.
But if you had half stepped like that, then yeah, your data that you read back with the Kyroflux or the Grease Weasel would be suspect, right? Because now you've got two separate sets of data and it's trying to read. Well, I guess it depends on where the head is, right? Because if you're doing a half step track, the head has to have enough resolution to be able to write to a half a track, right, in that disk.
No,
But
what this was that they would force it to be a half track off when they wrote a special track, and then they would go to that position to reread it. So they were reading a track they'd written a half step out.
oh,
I think this was only
Yeah, that way if
used on the
somebody did
Apple,
a
right?
disk copy, right, it wouldn't copy that information because the
Yeah.
regular disk controller wouldn't
Yeah.
think to look there,
Yeah.
but the program
Yeah.
did it. I've read about that. Yeah. Sorry, Adam, I stepped on you, man.
No, I was gonna. The only place I've heard that was ever used, I think, was in the Apple community. So I'm not sure if it's relevant here.
I think it was. I was probably listening to Retro Computing Roundtable or something. I think that might have been what they were talking about.
Mhm.
well, it's, as with anything, if you can have control of how the disk drive steps and things like that, then sure, these companies could come up with all kinds of weird, right, formats to write things onto the disk because they knew how they wrote it and they had them, they knew how to read it. The Kyroflux, I've only used it really for the IBM stuff because I used it because I didn't want to put it into a machine, right, and like copy it from on a physical machine. I just wanted to put a disk in a drive, run Kyroflux on it. I'd have the magnetic data, stick another disk in there. It just made it quicker for me to back up a lot of my old IBM disks because I didn't need I didn't need a machine. And any kind of copy protection, most of the time you're copying that, right, with the Kyroflux, right? Because you're copying the magnetic data that's there. Like I said, putting it together is a whole nother, that's a whole nother part of the process. So you may run into issues there. Well, hey, I got this program, but then you might go back and research it and say, well, they use copy protection on it, and this is how the copy protection worked. And then you could adjust the parameters on that program that puts it back together to hopefully compensate for, to take that into account, and you would actually get a valid, bit stream out of the magnetic data that you got from that copy protection. But anyway, that's just, I just, kind of, a lot of people don't know that there's that out there. I know the Grease Weasel, I don't think maybe it's more popular in a certain community, but I certainly know Kyroflux is a very popular thing too, and but it's mainly made for, like you said, the 34 pin floppy disk interface, right? That I don't know if that's a Stuttgart standard or whatever the heck standard that was, but any drive, you're right, up to 8-inch, maybe even bigger drives, but I think the Stuttgart standard started around the 8-inch era, but you can all it does is reads the magnetic data and puts it in a big file, which is kind of just, it's cool. But there's also, just like tapes and everything else, you're going to have, how strong is that magnetic data after all this time? So you may have, quote unquote bit rot and stuff like that. And some of these things you're trying to read so that, you still may lose out on, the actual data because it's just degraded too much.
Hey, Tom, you had some questions?
Yeah, I had a question maybe you guys can help me with. So eventually with my interpreter, oh, sorry, let me get off of. Come on, camera. There we go. Sorry about that. I don't know how deeply I'm going to delve into the graphics of the Timex, but I would like to try to come up. I'd like to do something with it. I'm just not sure how far I can take it. But anyway, you know how on the various keys, there's different characters that you can get that are different graphical symbols, and they're accessible through like the character string command
Mhm.
and all of that. I'm trying to figure out how I would implement that. And of course, I'm not going to be digging into ROM and all this stuff to try to do it. That's a bit beyond my depth, but any idea how one would go about designing those graphical symbols? And
You could talk to Ryan.
on the software level.
Well, it's just what, a 5x7 or an 8x8 matrix, isn't it, Ryan?
Yeah, something like that.
Well, I mean, how are you doing your system isn't doing graphical output, right? It's just doing textual output.
Right now it's just textual, but at some point I'm going to get to where I want to possibly try to implement a little bit of graphical as well.
Are you is
Can you
this
do
like a TTY type screen, or are you using something with a modern font?
It's just a typical terminal shell.
Okay. Oof.
But your goal is to be able to run these programs to what level of compatibility, like to be able to use those block graphics the way they originally were intended?
I'm torn, to be honest with you, and that's part of the reason I'm asking this question, is to see if you guys have any ideas that bring this within the scope of what I'm able to do.
Yeah,
basically, if it can't be
I haven't
implemented at
looked.
the software level, it's
Can you do graphics with your Lisp at all?
there are graphic libraries certainly for Common Lisp.
Because remember, there are really no graphics on the ZX81 or 1000. It's just characters. And that when you say plot or unplot, it just determines, oh, this is what's at that location. If I add an additional plot here, I need to convert to this other character.
Oh, I didn't
How
know
it's all
that.
implemented. So there really
Oh,
tends
yeah,
to be
it
no
was-
graphics.
Yeah, it has a little routine that says, hey, you've got yeah, I'll show you part of my little cheat sheet for
Yeah.
Right.
context here. So if if you had like this guy here, and then the plot command would want you to fill this corner pixel there, it'd figure it had to change this character at that display position to that character. And that's how that'd work. And if it was already like a letter character, it would just obliterate it and put a block graphic there.
Right. Gotcha.
Now the decision you need to make is like, well, what's in the spirit of, to me, it's like the emulator versus, I don't know if you want to call it simulator. The emulator where you got to be exact. So like when you type those programs in, they work correctly, which depending on, again, you're not going to do machine code. I don't think so. You're not going to worry about those kind of programs. But a lot of those, would get very particular. And so then you got to start emulating all the little nuances and quirks in the same way. And then when you do that, it winds up, limiting it ultimately to just whatever that could do. Now, one of the things that interested me about what you were doing was like, well, it had the possibility of, like, as you said, just using a scripting language. But obviously you'd like to be able to do some graphics. So maybe one of the choices is to say, well, it's going to work in that spirit and that syntax, but it can do more. I'm going to take it to the next level. And so maybe the graphics become like this whole thing, like maybe it's like a vector drawing space that you can open up a window and draw in, and that never had, or something like that. You might have to decide that. Now, initially, you might could get away with starting simple, like, could you just, I think maybe there's some approximations in the Unicode, maybe if you look in there.
Yeah, but they're the wrong aspect ratio. They're
Well, no, but he's using a terminal, so it'll be,
it'll be
He's not
taller than
emulating
it is.
He's not
You're gonna have to
emulating
do
the
something in
look and feel
graphics,
yet.
whether it's SDL or some other sort of graphics thing, because you're not talking about just a terminal line. You've got to do a 64 by 24 screen. If you're gonna do, I can see where you're going. So the gentleman does the ZX simulator, doesn't do emulation. It is basically a ZX81 basic interpreter in another form. That's kind of what you look like you're going. So his
Yeah.
thing doesn't take assembly, can't handle that. It just takes the Sinclair language and implements it on the screen. There used to be I want to say something called BinSync, BINSINC, that did that for the ZX, that did it also for the ZX1 or the ZX Spectrum 1 and 2. I just did a quick search and couldn't find it. I think there's something out there like that where someone is just doing a basic interpreter also.
Okay. Yeah,
Yeah,
I mean, that's
basically-
basically what I'm doing as an interpreter. I'm doing basically creating a very close approximation of the interpreted language. I would like to have some capability to print out the cool little graphical symbols, but in the end, I don't know how deeply I'm going to delve into the graphics. I'd rather actually create a little bit more of a useful language that I can integrate with other stuff, just for the fun of it, for my own purposes. But yeah, I see that you guys have posted some. Oh, I see the
Some
free
fonts.
fonts download. I'm
Yeah.
going to take a screenshot of that real quick.
Well, and I'll put it in the notes that I attached to the video when I upload it to YouTube. So it'll be there too.
Okay, thank
Yeah,
you.
'cause
I'll
it-
definitely look those up.
Yeah, and Tom, you can also just save your chat window real quick. It's easy.
Yep.
That's a nice thing to do.
Oh, okay.
Yeah. I don't know if
And
it's the three
I
dots.
don't know if someone could look up on Wikipedia, if you look up block elements. I don't have the ability to poke that in here. That gives you
Wikipedia
some
for
Unicode.
their character sets aren't really nice. I've been using them recently and they're kind of horrible. I just go ahead and get the ZX81 or the Spectrum documents, the basic guide, and those give you all the characters.
How do you save the chat screen?
In
Oh, I
your
see it.
chat.
Save chat.
Okay.
Got it. Got it.
Yep.
Thank you.
Double dot.
Gotcha.
If you Google
Well,
ZX81
what I'm saying
character set,
is,
I was going to say, if you
sorry,
Google
Tim.
ZX81 character set, there's a Wikipedia page with all the characters too.
Oh, is there really? Oh, that's
Mm.
cool.
well, what I was saying was that if you're just initially outputting characters to a terminal, those are already in whatever font the terminal is in terms of aspect and look and feel. You're not yet, unless you went and got the font and loaded it up and used it in your terminal, you don't have the characters for the ZX81. And then you also had the issue, of course, it's not even like the Spectrum, so it's not even ASCII compatible in any way. So that you could, I think, use the Unicode block characters. Of course, you'd have to make sure your terminal was Unicode savvy as well, but that might be a place to start anyway.
Okay. Well, these are some good ideas. Helps me to kind of put it in perspective and think of exactly what I want to do with this.
Cool.
Thank you.
So we're down to about 9-ish minutes. Our next meeting will be the third Sunday of a month. Let me just double check when that is.
20th.
The 20th. Yes. Yeah. So roughly 2 weeks hence, 13 days from now, something like that. Is that right? 13, no.
Yeah, there was 3 weeks between this meeting, right? Because of the way, how many days there were in the month?
Yep, because of the way October worked out.
Yeah.
Mhm. Yeah.
Because I
that's-
think otherwise it would have been on the 31st, which if that had been the first Monday, but it turned out to be the last Monday of the month. So
Well, yeah.
Yeah.
So, and then, yeah, right. So our next meeting's on the 20th, which is a Sunday at 2 p.m. Eastern, and
11 a.m. Pacific.
yeah, that's right.
Right in my lunchtime.
But Tim,
I
you
did
like
have one
joining
other
us for lunch.
thing I wanted to add, since we haven't brought it up, and I got it the other day, is I got this book.
Oh,
Yeah, I came on Saturday, and for whatever reason, it like the envelope had been soaked in like laundry detergent or something.
oh,
So, I don't know. So the book has like this
Tide Clean.
nasty smell, but I've been
Clean
airing
and
it out in my
fresh.
bedroom. But I started reading it today, and it's way beyond my level. But it's kind of cool anyway for what I do understand. But now I can see why people were able to design Spectrum clones using this book, because like
Yes.
this book is so detailed. It's beyond detailed.
Yep. It breaks it down into exactly how the ULA is made. You know, all the
Right.
gates and everything inside. Yeah.
Yeah.
I mean, it also like it starts off just talking about how, because I took electronics classes, and when they were talking about how chips were manufactured, I was like, I don't need to know how the inside of a chip works. I mean, that doesn't matter. I'm never gonna need. Well, this book starts there and is like, here's why you need to know, and I'm like, oh crap, I should have paid more attention in class. Like,
Yeah. And I
but-
used to work here at Intel, right? And of
Mhm.
course, we used to take classes. You know, they were confidential and all that, but basically all the layers of you know, how the 386 was made and the 486. That was kind of the era that I think maybe some Pentium stuff too, but we called them red books at Intel because they were top secret kind of stuff, right? Because didn't want your competitors knowing how you made your the die layouts and how everything interconnected and all the layers and everything.
Adam, I've been thinking
Yeah.
about getting that book. Does it have things like logic diagrams or?
Yes.
Oh,
Yeah.
it does.
I
Well,
don't know how deep. I mean, I only started reading it, like I've read 20 pages of it, and I've skimmed, like flipped through the pages, but like I don't know if you can see. And actually, Jeff, at the beginning of the book, it talks about this book is freely distributable. So I think somewhere
Yeah,
it's out there in a format where you can just download
Yeah,
it,
I think you can get it in a PDF.
but I
so you
don't know
don't
where that is. So maybe
Technically, have to buy it, but yeah, I
no, you
think
don't have to buy it. It's
Right,
actually
that's what I mean.
yeah,
You can just get it, right?
yeah, but I don't know where
Is
it's
there a
available.
book like that for the 1000 or the ZX81 ULA?
That I don't think so. I don't think they broke that one
Because that
down.
one's just for the Spectrum, right?
Yeah,
Right.
this one here. Yeah.
And that's different enough that it can't be applied to the 2068 either, right? Or are they the same ULA?
No, they're different.
Yeah,
Yeah, they're
different.
totally
Yeah.
different.
Yeah.
But some of the routines, like your keyboard thing,
Yeah.
that kind of carries over because it's done the same way in the 1000 as it is in the Spectrum and in the 2068, as far as the
Right.
keyboard scanning.
Right.
But I was turned on to this book by I mentioned it to the group, but if the person who wrote this book is named Carl Smith, and there's a really good episode of Floppy Days. I don't remember which one. I noted it in the group where they do an interview with him, and if you get a chance after you listen to the interview, you'll end up buying the book. So don't listen to the interview.
Yeah, it's a great book if you really want to understand what's going on inside that custom chip, right? So you
Yeah.
can, like I said, people have made the Harlequin basically because of that book.
Mhm.
They could actually, do everything with discrete logic.
And David, you've built a Harlequin, right? You've built
Yeah,
one?
yeah. I've successfully built one and unsuccessfully built two. Various flaws. Who knows what the hell? And I, just
Like
That's
errors
right.
on your part, you think, or something?
oh,
else?
yeah, absolutely. Yes, it's
Oh,
me.
okay.
It's
Okay.
I
Way to take the blame.
well, it's probably a bad solder joint, or I put the timing. The timing is really, really tight, and you have to use the right variation of the 7400 series TTL. And Don, I mean, he's the guy who does this. Don Dindang has just done amazing work. But it's like a mix of 74 LS and 74 HC, and he really depends upon the timing variations between just those two series, for instance. He posted on Facebook a while ago that he was working on a TC2068 clone, I think.
A what? What did you call it?
TC, a Timex computer, so
Oh,
a Portuguese, which is close enough to ours. And I asked him, I estimate. This is on Facebook. If he was going to be doing a a similar version, or it would be compatible with the 2068, the American 2068, and he said yeah, but I haven't seen any updates on that. Oh, that's right. Tim just posted to the chat. That's Tim. Is that the tin mouth guy?
No, it's not Timeless. No, it's another guy.
Okay.
And he's got the PCBs up, and there's a 35 and a 38. There's 4 different ones, I think, they're out in the world from 3 different people do them. So
yeah.
And also remember, the ZX81, just as a cost reduction effort, is basically the ZX80, right? I mean, there are some improvements there, obviously, but I mean, the ZX80 is a discrete machine, right? It's all discrete. So he just combined most of that extra, all that glue logic into the ULA, right? So you can gain a lot of the information from looking at how the ZX80 is made for a ZX81, right?
Well, Carl, at the if you're interested, at the next Albuquerque Timex meeting, I'm going to be showing this book off. So
and book club.
I think I have it, or I tore it down and scanned it, but I think I have it somewhere because that is a great book. I mean, very well.
And Jeff B, I'll take a look and see if I can't find maybe tomorrow in the book if he actually points out where the book is located in PDF format, because apparently it's got a license to be freely distributed. At least it claims to at the beginning. So
I'd appreciate that. I'll probably just order it from Amazon. I'd like to support the author.
Yeah, that's what he says. He says if you like the free version, buy the book.
Yeah, it's worth it. It's
That's
really
cool.
worth it.
Well, we've got about a minute or two left. Is there anything else we need to finish up on?
I think I'm good, but I do remember this ZX81 plus 38 that Tim posted. I remember seeing some interesting discussions about that.
Yeah, he's like an unemployed student or something. And he had a bit of spare time on his hands. It's interesting backstory to his one. And Grant Searle's one, the one I posted second, he has a full in-depth screen scope traces, full-on one with the ZX80 with and then he goes on to show the NMI extensions to make it into a ZX81, which is the basis of the Timeless one.
Yeah. And he also has a really nice CPM of his own design, Grant.
Oh, wonderful. He's got heaps of single board computers. He does a full one.
Yeah.
Cell stuff's crazy good.
That guy's a monster. Yeah.
Yes.
Amazing.
I like to buy pre-assembled computers for some reason. I don't know why.
Well, and this discrete computers is becoming kind of a little trend now, right? Because I know the Commodore, somebody came up with one for the Commodore pretty much. And the Commodore has a lot of custom chips in it.
And they do the SID chip and discrete logic?
Yes.
Wow. Wow.
That's the definition of insanity.
Yes.
Well, I think they're trying to get, what do they call it? They're trying to be able to build these vintage machines from all brand new parts, right?
Okay.
That you can get today. So
If you've seen the Monster 6502, he does a 6502 in transistors.
Yeah.
That's right.
Yeah.
That thing's mind blowing. Yeah.
That thing's
That's
a work
crazy.
of art.
It really is.
Beautiful.
Especially with all those LEDs in there. You can see every single path. Yeah.
He put all the buses on there with LEDs.
Yeah. All the registers, everything. Yep.
Awesome. Well, gentlemen, it's been another wide-ranging and very entertaining evening.
Thank you, David.
Good times. Good
Great
times.
See you in 2 weeks.
Bye, guys.
all right, guys, have
All
a good
right.
one.
Night all.